Hello, grade 10s. Here we're going to do some finance revision, and the next example we'll do is some functions revision. This is extremely important for your exam, so please take care. Redo this 10 times over if you have to. It's extremely important that you get this right. And you will be A-okay for your exams. So first things first, a savings account is opened. Oh, this is taken from the 11th of July formal assessment. You have the memo for this. You have the question paper. Go and have a look at where you went wrong in your test and do what you need to do to rectify your mistakes. Please reach out if you don't understand, but hopefully this little video will help you. So a savings account is opened and an amount of 9,350 Rand is invested at an interest rate of 6.2% per annum compounded with compound interest. So immediately you must know we're using the compound interest formula. Memorize it. After 3 years, 2,560 Rand is withdrawn. The interest rate changes. I've put that in red. I've put that in bold. Whenever you see the word, if you see this in a question, the interest rate changes, then you have to know you're going to have two separate working out parts. You're going to have two calculations, one for the one interest rate, one for the other interest rate. And you're also going to need to draw a timeline. Look at how many marks you get just for getting the timeline right. 3 marks. So let's have a look. The interest rate changes to 4.7% per annum at the end of the 5th year, and the money is in the account for 10 years in total. Draw a timeline representing the above information. Right here. So I've made my timeline have 10 notches. Look at how the beginning of the timeline, there is no notch at the beginning. That means no time has passed. By the first little notch, it means 1 year has passed. Then if you count, 2 years have passed, 3 years have passed, all the way to the last notch, which represents that 10 years have passed. Now let's put our monetary amounts in. 9,350 Rand was put into the account and no time had yet passed. So it's all the way at the left of the timeline. Then it says that after 3 years, 2,560 is withdrawn. So let's count 3 bunny hops. 1 year has passed, 2 years have passed, 3 years have passed, and we show that the amount is taken out of the account by using a negative, minus 2,560. Then it says the interest rate changes. You also have to indicate this on your timeline. So it says the interest rate changes at the end of the 5th year. So let's go and draw a nice big bold dotted vertical line after 5 years. 1, 2, 3, 4, 5 bunny hops, and go and make this obvious on your timeline. You need to make it, you need to make yourself aware that there is a big change happening here, and that is the change in interest indicated on your timeline as well. I've shown arrows. You can just use curly brackets. You can do whatever you like as long as you indicate that at this stage there has been a change in interest. Now I've put a big fat smiley face there because I want you to remember that we need to work towards the smiley face. So let's forget about this half of the timeline for now. Let's work towards the smiley face and then use that answer for the second half of the timeline. Okay, so I'm going to take my 9,350 Rand and I'm going to make it travel from this moment in time all the way to the smiley face dotted line. So that goes through 1, 2, 3, 4, 5 years. So this is where this exponent of 5 comes from. See how we apply the formula every single time we see a deposit or a withdrawal. So I've applied this formula to the 9,350 and I've taken it all the way to the smiley face. That's why I've got a smiley face on the left-hand side of the equal sign. Now let's take 2,560 all the way to the smiley face. Look at how it only had to hop twice. Hence, my exponent over here is 2. So 2,560 was being subtracted. You'll get a mark for knowing that you have to take it away. You are withdrawing 2,560 Rand, as well as the potential interest it could have accumulated. So that's why we're subtracting it, and we're working towards the smiley face. So this 5 represents the 1, 2, 3, 4, 5 years that 9,350 Rand sat in the account for, and then this 2 represents the fact that you took out 2,560 as well as the interest that it could have potentially accumulated over those 2 years before the smiley face. Great. Pop that in your calculator, pause this video, and get your answer. Right, once you have that answer, do not clear your calculator. Use it. We're going to use it now. We're going to take this answer, we're going to take this smiley face, and we're going to apply it to the rest of the timeline. Look at how this smiley face will travel. 1, 2, 3, 4, 5, another 5 years. So we're going to use our compound interest formula where our N is 5 to get how much money we would see in the account after 10 years. So now we're going to use that previous answer in the formula again. So look at how I haven't even given it to you. I haven't written out the answer yet. I've called it answer and I've called it smiley face. I'm going to take that answer and I'm going to multiply it for the rest of the amount of time, and the rest of the amount of time was 5 years. If you wanted to be super clever, you could put big square brackets around all of this working out here. In other words, the smiley face could have been in big square brackets, and then you could have just multiplied by this 1 plus 0,047 to the power of 5. You could do it all in one step on your calculator, but I think it's a bit safer, perhaps it's a bit more logical to work towards this smiley face, get the answer of the smiley face, use that answer for the next 5 years with the new interest rate. Pause, work it out, and then play to see if you get the same answer as me. And that answer should be 12,258 Rand, 96 cents. Good stuff. Okay, so the other question that everybody struggled with in the exam, in the formal assessment, and another question that you will 100% get something very, very similar to in the exam is going to be this question on functions. So what you need to do is read the question carefully, look at what information has been given to you, and look at what information you require. First things first, let's go over what kind of functions do we see, basically. Yes, we see a parabola, a sad parabola, like it looks like a smile, a sad smile, the opposite of a smile. I don't know what it's called, a sad face parabola. And let's have a look. They do tell us that H is the parabola. H is equal to kx squared plus q. We have no idea what this formula is, so we're going to have to use the information on our graph to determine the formula. Look at this one. F at x is a times b to the power of x. So f, of course, is an exponential graph. Okie dokes. Now we need to say, and they also tell us that the parabola has an x-intercept of 3. So we know that this point is 3. And we know that the point 1 and 12 lies on the graph of f. So 1 and 12 lies on the exponential. Perhaps we can substitute it into this formula. Anyway, let's have a look. Give the coordinates of a the x-intercept of h. Now, do you see we already have the 1 x-intercept at 3? So because a parabola is always symmetric around the y-axis, we know that that little stretch from the y-axis to the left x-intercept, it must also be 3 units, right? So A is very clearly -3 because it's on the left-hand side of the y-axis. Easy peasy. Next one is asking us to determine the equation of h. So basically we need to find a value for k and we need to find a value for q. Q is always your y-intercept. So for one quick, easy little mark, you just say Q equals 3. Why? Because we are given it. We can see the y-intercept on this graph. Now that we know Q is 3, let's replace the Q in the equation with the number 3. Then you can use any other point other than the y-intercept, because we've already found the y-intercept. Use either A or this coordinate over here to replace the y and the x in the formula y equals kx squared plus q. Once you replace your y and your x with a given coordinate, we can find k. I'm not going to show you that working out. I want you to pause and see if you can get to the fact that k is negative 1 over 3. Pause the video and go for it. So once you know that k is negative 1 over 3, you can write the final equation in the correct format. Y equals kx squared plus q. So hx equals a third x squared plus 3. And there's 3 marks. It's very, very quick to do if you know what you have to do. So please know how important this question is. Please go over it. Now we need to determine the equation of f, which is the exponential. I want you to remember to always, when you ask to determine the equation of an exponential graph, you must say to yourself, why do I have to do this? Why do I have to determine this equation? Y-intercept. Is the y-intercept given to you? Yes, it is. Go and use it first. Y-intercept must be used first, because then it makes it so easy for you. If you substitute in the fact that x is 0 and y is 3, you can get rid of one of your unknowns and your base falls away, because b to the power of 0 is 1. So you can see that a is going to be equal to 3. Easy peasy. Now we have y equals 3b to the power of x. So then we use any other point that's potentially on the graph. And what do you know? There's one other point on this graph that can be substituted into y equals 3 times b to the power of x to find b. Once you substitute 1 and 12 into the relevant spots, you will get b to be 4. Please pause, do the working out yourself, and make sure that you do that you do show all your working out. I know I am skipping steps here. Remember, I have given you the memo to this as well. Last but not least, we need to give the range of f for 1 mark. Let's have a look. The range occurs you start at the smallest possible y value, and then you see what is the biggest possible y value that corresponds to this curve. Now, I have given a horizontal line, and I'm showing how this horizontal line moves up, and no y value, that horizontal line has not touched the curve yet, all right? Only once we cross over the x-axis, only once the y values are bigger than 0, do you see how the green line starts cutting the exponential curve. So the smallest possible y value of this exponential graph is 0, while the biggest possible y value, see how this will tend towards infinity? The biggest possible y value is infinity. So the range is y is an element of 0 to infinity. So easy if you just get it. The last 2 concepts regarding this little question, I hope that it makes sense to you, and that is where we now have to determine the values of x for which h of x is smaller than 0. What on earth does that mean? That means the y values are smaller than 0. And how do we see where our y values lie? We look at where the curve is below the x-axis. So let's look at this parabola h and just color in the part of the parabola that's below the x-axis. Now, so that's that purple part there. Now I want you to imagine shooting it down and saying pew pew and trying to attach that purple squiggle to the x-axis. Do you agree that that part of the curve links up to this segment of the x-axis? Likewise, if you were to go on the, so that, if you write in maths words, the very smallest x value over here is pointing to the left of negative infinity, and it comes all the way up to the x value at a, which is negative 3. Then we repeat ourselves because look here, this over here underneath the x-axis, we have h again. So there's more to this answer. This that I've written down here is only half of it. So we need to write down the word or, and we need to say, okay, so if we were to connect this purple squiggle to the x-axis, do you agree it corresponds to this segment right there? And we write our answer as a set of x values. We start with the smallest one on the left, which is 3, and the biggest x value would be on the right, would be positive infinity. So look at how it looks so scary, but once you break it down, it's really not that bad. Last but not least, we're going to ask ourselves, where is h at x decreasing? When you see the word decreasing or increasing, I want you to imagine a little stick man walking along this curve, but this stick man has to be walking from left to right. So look at him. He's very angry and he's in a rush. He's going to walk along the curve from left to right. Now, at what point in his journey did he start going downhill? It was from the top of the hill, right? And the corresponding x value right there is 0. Hence our answer for what is the value of x for when h is decreasing. X starts at 0, and as you go along, as you walk down this parabola, you'll be walking downhill towards positive infinity. Ta-da, ta-da! Now, what if you have to write down the equation of g of x if g of x is the reflection of f in the x-axis? You must first write down the equation of f. Even if you think you haven't got it right, write it down anyway so that we can use the answer that you found for yourself. Then we're going to remember that if you reflect something in the x-axis, the whole equation becomes negative. If you reflect something in the y-axis, only the x becomes negative. NB, 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 hint, hint, wink, wink, nudge, nudge. Right. So if we're reflecting in the x-axis, the whole equation becomes negative. So you put a minus in front of f's equation. That's why I put a minus in front of f there. And I put a minus in front of that equation there. And that is that. You can't really simplify. If this was a parabola, you could distribute the negative into the parabola and simplify. Right, I hope that makes sense. Please reach out if you have any queries, but know that this is extremely important for your exam, so please go over it 10 times over.